All right, so hopefully you guys have a better understanding of those rational exponents that we talked about yesterday. The biggest ones for you guys to know are that the cube root is the same thing as raising something to the 1/3, and the square root is the same thing as raising it to the 1/2 power. So what we're going to be doing today is we're going to be starting to take a look at these exponential equations. Now, when we're looking at an exponential equation, it's a specific type of equation in which, if it is exponential, the variable is in the exponent. Now, when we go through these problems, I know yesterday I showed you guys this and I said, you guys are going to need to know these. Well, if you don't know them, you at least want to write them all down and have them handy as I go through this, because I'm going to be relying a lot on these facts. So as we start to take a look at these, this is going to be where you're going to want to return to. Now, we're going to start with some problems that are a little less complex. Now, when we take a look at this, if I asked you guys, well, what's x? I'm hoping the vast majority of you would see that the bases are the same. And so if this is 3 to the 15th, then x would have to be 15. So we rely on a certain property that says if a to the y equals a to the x, then if the bases are the same, then we must be able to conclude that our exponents are equal. And so this is the big thing that we're going to rely on as we go through these. The situation is, though, they're not always going to be set up in that form, and we're going to end up having to do some manipulations so that it does look like this. Now, when we take a look at this problem, well, right now in this problem, I have the same base, and so I only have one of them on the left, I only have one base on the right, so therefore my exponents must be equal. So x plus 1 equals 8, so x is going to equal 7. Now, as we move along here, we're going to have to start to do a little bit more work. Now, right now when I take a look at this, the 5 is my base and the x is the exponent. Well, when I take a look at this problem, one thing that you guys are going to need to see is that the 1/5 is your base and a 1 is your exponent. Now, I need my bases to be the same, and right now they are not. So what I need to do is I need to be able to rewrite this 1/5 with a base of 5. So I know right now that this is 5 to the 1st. And you guys are used to making exponents positive, but we can actually make them negative as well when we move them across this magic line. So I'm going to move this 5 to the 1st up. And when I do that, I end up with 5 to the negative 1st. And so even though I have this 1 here, it's not going to make much of a difference right now. So I'm just leaving it as 5 to the negative 1. And then I have 5 to the x. So in this situation, then, we end up with x equals -1. So when we're moving our exponents, they're changing signs. Now, when I take a look at this one, right now, my base is 4, and here, my base is 2. So I need to figure out how I can rewrite them with the same base and maintain equality. So in a problem like this, my smaller base is 2, so I want to look and see, can I rewrite 4 so that its base is 2? Well, 4 is a power of 2. Hopefully you guys all know, and you should, that 2 squared will equal 4. So when I rewrite this as 2 squared to the x, it's still equivalent. And then I already have 2 there, so I'm going to bring that down. Now the 2 does have that hidden exponent of a 1. So now when I'm looking at this, I have the same base. Well, if I take the power of a power, I multiply those. So these are getting multiplied. So I have 2 to the 2x equals 2 to the 1. And so now I have it set up of this form. So I can drop my bases and I have 2x equals 1. And so when I go to solve this, I get x equals 1/2. Now, in this one, this is probably one of the more difficult problems for people to recognize. Because, well, one, I didn't even write the 7 here. But what I do want you guys to see is, so we have this equal to 1. Well, if we take a look here, all of these are the ones that equal 1. Well, those are when we have a exponent of 0. So if I know that I've got my base raised to some power and it equals 1, my exponent has got to equal 0. So x minus 8 must equal 0. So x is going to equal 8. So if I checked it, I end up with 7 to the 8 minus 8 equals 1, which is 7 to the 0 equals 1. And that's true. That works. So anytime it's equal to 1, you guys need to get this down to 1 base and then set your exponent equal to 0. Now, I am going to go on to some more complicated problems in which we're going to require a little bit more manipulation and the properties of exponents.